DAX, or Data Analysis Expressions, is the language that's used to create formulas for Power BI that extend our data model. DAX gives us the ability to create additional information at runtime so that we can quickly and easily generate new information beyond the information that's in our model already. If you already know how to build data models in Power BI Desktop, DAX is a logical next step because there are things that we can do with DAX that we can't do as easily or at all without it. I'm Ginny Von Corder. I invite you to join me for this exploration of DAX in Power BI. If you'd like to work along with me for all or part of this course, then there are a few things you'll need. First, you will need a Power BI account, and if you're not sure if you have one, or if you're not sure if you have one right now, you've had one in the past, for me the easiest way to find out is to attempt to log in here at app.powerbi.com. And it should pop up and say nice things to you and call you by name. If it doesn't, you'll have the opportunity to log in, and if you have not already created and used a trial account for Power BI, you can do that provided that you have a work email address or a business or organizational email address that you can sign in with. You can have access to lots of options here in Power BI. But you'll need more than this because this is powerbi.com, and most of our work is actually going to be done on the desktop. So you will also need to download and install Power BI Desktop if you have not done so already. There are two different versions of Power BI Desktop, one for 64-bit Windows, one for 32-bit Windows, so you'll want to pay attention to that and know what you need. And I'm going to send you to a resource for that in a moment if this is sounding a little unfamiliar to you. This is not a beginning course in Power BI. My assumption is that you knew some things before you arrived here. For example, you know how to fire up Power BI Desktop and get data. Once you have it in Power BI Desktop, you then know how to use that data modeling tool set to transform your data, to shape your data, to add and remove columns, to change data types, and so on. You know how to switch to the relationships view and modify the relationships between the tables in your data set. And you know how to create and edit reports, including creating simple visualizations. This course focuses on modeling, not on reports. The visualization that we will use the most is simply a matrix visualization. But I trust that you know how to drop one of those into a report and modify it slightly in order to view your data. If you'd like to know how to install Power BI Desktop, if you'd like a refresher on any of these particular skills and experiences, I have two places that I'll send you. The first is Learning Microsoft Power BI Desktop, which is specifically about the Power BI Desktop tool. But if you're new to Power BI, then I would encourage you to take a look at Power BI Essential Training, which includes not just data modeling is the process of taking your organization's data and creating a model that can be used then for reporting and forecasting by the business. Sounds simple, but not necessarily. Data modeling includes many steps. First, we start with determining what data we want to load, and that includes what data source it comes from, because we can include data from more than one source. It also includes how much of the data we want to return from each source. Do we only want to include the last 3 years of data, for example? Do we want to summarize transactional data and just return the summary? Or do we actually want to see each and every one of the transactions? Once we've made these choices, or even while making these choices, we will begin loading data into the model using whatever modeling tool we're using. And in this course, we're using Power BI Desktop. If we have more than one table, and you almost always will have more than one table, you'll then need to define relationships between the tables. For example, you'll need to indicate the relationship between territories and the states in the territory, between customers and their orders, between purchases and vendors. With those types of relationships in place, now we're ready to be able to transform this data. We'll shape it. We'll combine some columns, merge data from different sources. We'll also transform data. We'll change the data type, for example. We may also change the names of columns so that they're more human readable and easier for business users to work with. And it's in this last stage here of data modeling where DAX really shines. Because DAX isn't primarily about getting data, it's about how we're going to transform our data. DAX, which stands for data analysis expressions, but everybody says DAX, is a formula language similar to the formula language that we have in Excel. It uses functions. And this is a good way to think about it. You think, if I were in Excel, I would do this sort of thing. And for many of the DAX simple formulas we'll create, we'll use very similar functions. But DAX has other functions as well that are designed to deal with data models, data warehouses, and so on. We use DAX to be able to create new information from the data that we already have. For example, if we have two columns, one column for the quantity sold and another for the unit price, we can use DAX to create a formula that will calculate the total price for that item. Basically, quantity times price. And to be clear, if we had control of the data model, and if it was a good decision to do so, we could also add that column in the data model. So sometimes we're doing work in DAX that could be done in SQL Server, could be done in Excel, in Access, wherever our data is coming from. DAX is also used for period-to-period comparisons. This year's sales. The data set that I'm going to use was put together by Microsoft specifically as a demo for Power BI Desktop. It's called the Contoso Sales for Power BI, or Contoso Sales Sample. And simply go to your favorite browser and search for it. And once you get past the ads, if you enter Contoso Sales Sample for Power BI, it will be the first non-sponsored item in your search results. Click the link to go to the Microsoft Download Center. There's one button, download. You don't get to select another language. And the amusing thing to me is that it has really detailed installation instructions. Just download the file. So I'm going to click download. It doesn't take long. It's a relatively small file. And I want to save this in my downloads. Open the folder. And you'll notice that we have one file in here. I'm going to extract it. And for me, I want to simply drop this on my desktop. This is a look then at my desktop, but just to make sure that it got there, because I like to do that sort of thing. Here I am at my desktop. Here's the Contoso Sales Sample. Double click. This is a PBIX file, so it knows to fire Power BI Desktop. I'm being prompted to update Power BI Desktop, which I will do in a moment. But I know I have data here because over on the right-hand side, here are my tables and my fields list. If you missed the alert like I did, you can always click to download your new version of Power BI Desktop. This is the model, or as many people think of, the relationships view in Power BI Desktop for the Contoso Sales Sample. Here we see tables and the relationships between them. And there are a few things I'd like to point out to you here in this particular view. First, we have a main table here. This is the sales sample, and so it's the sales table. The sales table has information about sales in it. It has columns like product quantity and price of the product. This table is our fact table. It's a data table. The other tables are supporting tables. They are called lookup tables. And so, if I want to know information about the store that something was purchased in, it'll be in the stores table. The products, what category those products are in, that's out here on this branch. When I add data into a model, several tables, for example, from SQL Server or any other data sources that are related, Power BI Desktop tends to lay them out like this, a star or snowflake arrangement with our fact table, our main table in the center, and the lookup tables around it. There is another equally valid way to lay these out if you wish, and that is to lay them out with the lookup tables on the top, and then below them, the other tables, and really the fact table alone at the bottom. So each of these lookup tables at the top, make sure you're dragging the tables by the top. If I look at a particular table, I can find the lookups tables related to that above it. Hopefully one of these two methods seems intuitive to you. It might depend on whether you were working previously with relational databases. That usually will mean you'll favor the star layout, or if you've mostly worked with files from a more flat file world. Or people who have worked with SharePoint, I think, often say that they like this because they understand how lookups work in SharePoint. And there's also this sort of built-in mnemonic, right? You look up to find the lookups. In addition to arranging the tables in some way that is comfortable for you as a modeler and for other modelers, you can look at the specific relationships between the tables. Double-click on the relationship icon or on the line between the tables, and you'll see that we have two tables that are related, sales and the calendar. And sales to calendar is many to one. For every single date event in the calendar, there could be many sales in the sales table. So sales to calendar, many to one. If you need to modify this relationship or remove a relationship, this is the place to do it. And you'll remove a relationship if it shouldn't be there. You've added a table to the model that's not related but has columns with the same name as another table. We're going to use DAX immediately to create what is called a measure. A measure is simply a calculation that is going to operate across our entire data model. There are two ways to do it. Neither of them are wrong, but I find one of them more easily leads me astray. If you go to modeling, you can click new measure, but if I do that right now, it's going to create this measure in whatever table is selected, and I'm not even sure what table's selected. Oh, the calendar. Notice I don't want to measure in the calendar, I want it somewhere else, and this is why I don't typically do this in this way. I'll simply go to the table where I want to create the measure, in this case sales, right-click, and choose new measure, and it's going to put it in sales. It always puts them in alphabetical order. I need to rename this. Even if I only wanted to create one measure, I need to give this a name that describes what it is. What I'd like to do here is calculate the total sales. This is a common thing you'll do. Capital T for total, capital S for sales. Don't tuck a space in there at all. And I'm going to hit equals. And now I want to call one of those DAX functions, and the function I want when I'm totaling is the aggregate function, sum. So I'm going to begin typing, and as I continue, there's sum, adds all the numbers in a column. That's a little different than Excel. In Excel, it would be adds all the numbers in a range or adds all the numbers specified. But we're always dealing with all the columns or all the rows here in Power BI. So this part's right, and I can hit Tab. And if I do, notice then that I get the open parentheses and I get to choose. Now, the syntax for DAX is we start with the name of the measure we're creating, the equal sign, and then we have a formula. Here it's looking for a column name, and the column name is going to have two parts. It's going to start first by specifying the table, because we have more than one, and then it's going to specify the column name. What I want to total is the sales amount column in sales. So I'm going to begin by typing sales, and then if I wish, I can either click on sales amount and double click, or I could have, if I wished, from sales, tab down and hit sales amount. There are a number of different shortcuts here, and I need to close the parentheses to finish the end of this measure, and then I can press enter. And I have a new Now that we've created a measure, let's take a look at DAX syntax, because we'll be using the same syntax over and over again. It's like writing functions in Excel or writing a statement in SQL. The same parts appear every single time. First, we have a name for this particular measure that we're providing. In this case, it's total sales. Remember, no spaces. Then we have an operator. In this case, and in most cases, the equal sign, followed by the name of the DAX function. And remember that at this point, when I began typing, IntelliSense kicked in for me. I hit the letter S, and I got a list of things that began with the letter S that it might be possible. And the more I filled in, the more that list was filtered until I ended up with something that was really easy for me to get to. Now, remember that sum is a really short word. You might think, well, that wasn't really all that helpful. But some of the functions, so to speak, are more complex, longer names, more keystrokes. So it's nice to have this IntelliSense kick in. But I particularly appreciated that after I typed the sum function and hit tab, I got an open parentheses and then a list of table names and columns that I could be choosing from. And again, that's being provided for me by IntelliSense. Note that within parentheses, the table name isn't in quotes like it might be in some other formula languages. Instead, the table name appears and then an open bracket, the name of the column, a close bracket, and then the parentheses then are enclosing the arguments for the DAX sum function. we're indicating that in this particular table, when we say total sales, we mean take the sales amount and add them all up. Sum all the values in the sales amount column. And that's how we do it using DAX syntax. Let's use this total sales measure that we created in a visualization. What I'd like to do is add a matrix, because that gives me real numbers to look at as opposed to a beautiful chart visualization. They often look good to me whether they're correct or incorrect. So I'm going to choose total sales, and notice that it gives me a chart. I'm simply, with that chart visualization selected, going to click on matrix, and that is the total for total sales. But now I'd like to actually have total sales split out a little bit so that I'm looking at total sales by brand. So I'm going to choose brand name. Total sales by brand, I'm going to give this a little bit more space so that it all works. And that looks beautiful. Here are my brands. Here are our total sales. If I wanted to choose something other than brand, I could. We could turn off brand and choose manufacturer. That looks good. Or I could choose product name and we'll get a really large, endlessly scrolling visualization, again, that also uses our new measure. Get used to creating matrix visualizations. It's most of what we will do while we're building our data model. Another nifty attribute of a measure is that you can format it, and every time you use it, the formatting that you've applied will hang in there with you. I'm going to select the measure, and when it's selected, it's available to me for editing, but it's also available for formatting. If you're not already on the Modeling tab, go there, and here's the formatting that we could apply. For example, if I wanted to choose a particular dollar sign that's United States, or if I wanted to use the euro, some other currency, I can, or I could just indicate currency general. And note that when I do that, I get a different number of numbers after the decimal, and that's because this is set to auto, and I'd like to actually have no decimal points. It makes my numbers easier to read, and notice that that picks up in the total as well. When I'm all done, just click the checkbox, click back out in the canvas. Now, if I turn off, or if I create a new visualization out on the canvas, and I add total sales to it, notice no decimal points. There's the currency format I want, and we could then choose manufacturer, for example, and reorder those here. So we have our manufacturer first. That looks good. But the formatting that we see here is the formatting that is now saved as part of the measure. And I'm going to right size this visualization before I leave. Give me some canvas back. Sum isn't the only aggregate function in Excel or here in Power BI DAX. I'd like to use a couple of different versions of a count function. I'm actually going to show you 3 of them. What I'd like to be able to do is do a count of the number of products so that I could look, for example, at a brand and see how many products are included in the brand or how many products are included from that manufacturer. This is all about products, so we're going to start in the product table. I'm going to right-click here and choose New Measure. And the new measure that I'm going to create is going to be called Number of Products. I might kind of like num products too. Now notice that in this case, I didn't use camel case. I actually typed this out in a real human legible form, and I think I prefer this. So we'll go back and modify total sales to fix it as well. Number of products equals, and I'm going to use first count. But before we do that, count counts the numbers in a column. If I'm going to choose a column like product name that won't have numbers in it anyway, I then should choose count A. That's another possibility. So I'm going to choose count A, hit the tab key. IntelliSense helping me out the whole time. I'm going to go to the product table, and under product, I'm going to choose product name and close my parentheses. And I have now created number of products, and if I click in the canvas, turn that on, and I convert this to a matrix visualization, check out that I have 1,690 products. Now, a couple of possibilities of why this may not be exactly what I would like it to be. First, it's possible that some product is in here that doesn't have a name. It'd be more likely if I'd chosen description, but that's a possibility. So what are my other options? I'm going to leave number of products, and I'm going to show you another version of it. Let's click in the canvas, go to the product table, right-click, choose New Measure, and this time I'm going to just put num products. It'll be a little different. Equals, and I'm going to start to type count, but I'm going to use count rows. This counts the number of rows in a table, so I don't get caught up in what column I'm choosing, because as long as the row exists, it's going to return a true count for me. So there we go, and I'm going to be asked only for a table, not for a column. So I'm going to choose product, and close that off with the closing parentheses and press enter. Let's create a new matrix and take num products and drop it in. And again, 1,690 items. In this particular case, both of these do the same exact thing. However, if what I really want to know is how many rows there are in the table, then num products is a far better choice. If you'd like to delete a measure, you can simply point to it, click to open the menu, and choose delete. You'll be prompted, do you want to delete num products? I do. When I do that, notice that it breaks this visualization. That's okay, I can just select it and delete the visualization as well, or I could have edited the visualization to choose a different value here. For example, to put number of products and delete num products. Not a problem. But I'm going to delete that visualization, and then I would like to edit number of products, which is what I'd like to keep. So I'm going to select this to pitch it up in the editor, and instead of count A, I'm going to use count rows. I'm simply backspacing over the A, and note count rows is available to me right here. Double click, and I've now modified number of products. It says a single value for column product name cannot be determined. So notice that count A needed a table name and a column name, but count rows does not. So that's okay. We'll just drop back in and modify this. So now we have number of products equal count rows product. That's cool. I could have done it the other way. I could have modified the name of num products after deleting number of products, but I'm content with this. Remember also my envy of that nice product name. I'm going to drop down here to total sales and just pitch a space in there. Make sure that works. Click the check mark, modified it here, all good. And notice that it modified it the two places it's used in this report, in these two matrix visualizations we already have. One other thought about editing measures. Sometimes when I'm creating DAX, it's helpful for me to write notes, either to other people who are working on a data model, not using it, but the other people who are improving it, or to, as I also think about it, my future self. I can forget so much that I'm just another user when I'm going back to a project that I worked on 2 or 3 years ago. Let me show you how you can leave comments in your DAX. Simply hold Shift and hit Enter to go to a new line, and notice how it opened up line 2. If you'd like to create a comment, you can simply hit the slash key twice and then type your comment in. Comment regarding the total sales measure. Notice that my text here is in green, and it's not treated as code when it's being evaluated. If I hold Shift and hit Enter again, I'm on line 3, and perhaps I'm going to type some other. Now notice that this text is gray, and the DAX editor is saying, I don't have a clue what you're trying to do here. And I'm going to do Shift Enter again. If I've already typed my comments in, I can select them and hold Alt, Shift, and hit the letter A to have the entire block commented. Notice that if my comment is more than one line, I get an opening and a closing comment tag, so I could have a small novel that I had written in here. To add a new line at any point, go to the end of the line previous, hold Shift, and hit Enter. If I feel a need to provide more information to other people or my future self, this is the right way to do it. Not a sticky note, not an email, not something that I drop into Slack, but instead by using the formula bar and putting a comment into my DAX. One more thing, although I told you to be careful to choose your table and then right-click to create a measure, sometimes you'll be so eager to create a new DAX measure that you won't notice what. The Contoso sales sample database is annoyingly complete. We don't have blanks. There aren't places where a user forgot to fill in a discount or someone left a field empty because they didn't have the information and then that moment passed them by. But these are things that happen in real businesses. And it's not unusual that we need to check a data set to see if we have blanks. Let's take a look at how we would do that. I'm going to choose the product table. And let's imagine that sometimes no one fills in a class name. If I want to know if that's something that really could happen, I could go to the product table. But you'll notice that the class name, like everything else, is filled in. Let's create the measure here nonetheless. I'm going to create a new measure. And the new measure is going to be called no class. And that equals count blank. And we will specify a column. We're going to specify product and class name and close parentheses. Now, it would probably be better if I said no class name here. And there's our new measure. Let's return now to the canvas, create a new matrix. With it selected, choose no class name. And you'll notice that we have no results because we have no rows that are missing a class name. But if some were, this is how you would use count blank in order to find them. There is one more DAX count function I want to show you, and that is called distinct count. What distinct count does is it rips down a column data and counts each unique value only once. For example, we have a number of stores, but I'd like to know how many of our stores had sales during a particular period of time, for example. Let's take a look at our data for sales. If I go to the stores table, I can count stores, but here I have, as part of my sales data, a store key. And this shows me what store a sale was made in. Therefore, if I want to know how many different stores sold something, this is a great way to find out. By going to the sales table itself, the summary of our sales transaction, and say, if in this table a store's number shows up, then count it and tell me how many of them there are. Let's create this measure then. In the sales table, I'm going to right-click, choose new measure, and I'm going to call this stores with sales for right now. Makes sense. Click equals and start typing distinct count. Distinct count counts the number of distinct values in a column. Remember, it's a column, so we'll be going to our sales table, and the column that I want is store key. If I want to provide some specific formatting while I'm here, I can do that, but it's really what I want. It's a whole number. We don't have fractional stores. So if we now go back to our report, and I click, throw in a matrix visualization, and choose stores with sales, I find that I have 306 stores with sales. This becomes more useful then as a measure when we're looking at particular dates on the calendar. For example, if we're looking at a particular year or we're looking at a particular month and we're filtering this, we say, 200 of our stores had sales yesterday. 306 of our stores had sales overall. As with other complex applications, there is often more than one way to accomplish what we want to accomplish in Power BI. So I'd like to show you some alternatives to measures so that you know that they exist, so that someone doesn't stroll by and say, oh, you could quickly do this in a different way, and you wouldn't know if that's a better way to do it or not, because not everything we do should be done with a measure, but a lot of work that we wish to do is best done that way. Let's look now at an alternative to measures, and those are calculated columns. I'd like to do some calculations in the sales table. Here I am, and one of the things that I would like to do is to take the sales amount, subtract the total cost, and the result of that is actually going to give me my gross profit. Of course, there's overhead and other things, but the difference between how much we are paid for something and what it cost us is our first cut at gross profit. To do this, I want to insert a new column, and I can go to modeling a new column, but I can also right-click on sales, and rather than new measure, I can choose new column. And I will get a new column. It will feel a lot like I'm creating a measure. I'm going to start by giving it a name, gross profit equals, and I want from the sales table minus, in the sales table, total cost. And I'm double clicking on those to enter them. And I'm now going to either click the check mark or press enter or something. And if we scroll over, you'll see that my gross profit is my sales amount minus my total cost. So I've created a calculated column. Now, how is this different than creating a measure? When we add a measure, we're adding a calculation that is performed on the fly, at runtime, so to speak. And it doesn't take up any space and storage. So measures are nice and lean. What I've done here is I've actually added another column of data to my data set. And this won't just take up CPU capacity. Columns use RAM. They use storage. And so I've created a larger data set now that has a column with 2 million more values than it had just a moment ago. So why in the world would I do this? The biggest reason I would add calculated columns, well, there are two. The first is that calculated columns, because they are actual values that are stored in my data set, can be used for slicers. They can be used for filters, whether I'm filtering a report, or I'm filtering a page, or I'm filtering a particular visualization. Therefore, if I want to be able to create values that I can use to filter my report or visualizations, I'm better off creating a calculated column. And there's another possibility. In this course, we're creating very simple DAX formulas, but it's possible to create incredibly complex DAX formulas that take a long time to run. And if that's the case, it might be good to do some of the calculation ahead of time and have it stored in the data set. That would be a calculated column. So we could, for example, if we were calculating gross profit as part of a measure that we created, and that measure was taking a long time to run, it might make sense for us to break out 2 or 3 of the calculations and create them as calculated columns so that they're stored in the data set and they make our DAX functions and formulas run more quickly. Again, not a problem or something we're going to have here, but when you have incredibly complex DAX formulas, that's something to consider. Typically, though, if you have a choice, measures are leaner unless you're going to use the results of the measure as a filter here in Power BI. This is actually a really good time to let me show you another alternative to the measure that we created called total sales. I'm going to recreate this visualization. I'm going to start by choosing manufacturer. There it is. And scroll down. And then what I want to do is I'm going to simply choose sales amount. And I'm going to drag and drop it in here. And if you notice, this looks amazingly like total sales. I have the same value, a few more decimal places. And since some recent changes to Power BI, I can even rename this. I can rename this sales amount so it says total sales, and it will look just like this. I can give this a little bit more space. But this renaming, like any other formatting I do, is actually for this instance of total sales, formerly the summarization of sales amount, in this particular visualization. Watch what happens. I'm going to remove this. Sales amount isn't here anymore. And I select to put it back. It's once again labeled sales amount. And any other formatting changes that I had made to this column of data are gone. It's totally temporary. This is what you call an implicit measure. It's a measure that's created on the fly simply by adding particular values into a visualization. But it's not the same as having a measure that I can format and reuse. And there's another important difference. When I'm creating a new measure, I can refer to existing measures in that measure because they are explicit. They exist here separately listed as measures in my tables, in my data model. I can't, however, call up these implicit measures that are created simply by using a column of data in a visualization. If the only thing that you need to do is check some values, sort of do a status check as you're working in Power BI, then this type of an implicit measure is great. But if let's return to the sales table, because what we'd like to do is create a measure that would allow us to see our net sales. Net sales are sales amount minus total cost, but also minus any discount amount and any return amount. So this is basic math, and if we were in Excel, we would simply be clicking equal sales amount minus total cost minus discount amount minus return amount. But it's a little more complex than that here, because remember that every measure we create has to work in every context. And so we have to give it the context of a table and a column and a summarization method. Therefore, let's create a new measure. And the new measure that we're going to create will be net sales. Net sales is equal to, and right now if I start trying to enter sales amount, notice that I don't have a choice here of any column of data directly. I only have a choice of other measures. Don't start creating measures you don't need. Don't worry. What we need to do is we need to summarize this. So if I choose summarize or sum sales amount, close my parentheses, first minus. Now I need to treat total cost, discount amount, and return amount all in the same fashion. We need to summarize them. So sum, tab, sales. I'm looking for total cost. Total cost. Close my parentheses. Minus sum. And if before I hit that parentheses, when I have just, SUM, it'll uppercase it for me, which right now I know how to spell sum. But if I have a function that has a longer name, then it's nice to allow IntelliSense and the formula editor to uppercase that for me. Yep, I typed it correctly. Next, I want to subtract my discount amount. So in the sales table, discount amount, close parentheses. And finally, then any returns that we have to remove to achieve net sales. So we're going to sum in the sales table, open bracket, return amount, and then close the parentheses. Net sales is equal to sales amount minus total cost minus discount amount minus return amount. Press enter. Looks good. Doesn't return an error. Let's create a matrix. And let's drop in, for example, product, particular brand name. And now let's use our new measure, net sales. And this is the net sales figure for each of these manufacturers. Not total sales. Total sales is in the 8 billion range. Net sales is in the 4 billion range. Remember also, we're working with the third version of the Contosa sales sample for Power BI Desktop that we saved in a prior movie. It's also available in the exercise files. And what I'd like to do, now that we've calculated gross profit and the sales amount, is I'd like to calculate the gross profit percent. In other words, of the sales amount, how much of it is profit. This is a division problem. We're going to take gross profit and we're going to divide it into the sales amount. Now, it's unlikely in this circumstance that we would have a sales amount that was zero, but it's not totally impossible. It might be that we gave a discount that was equal to the entire amount of the sales because we were donating this to a charitable cause. Anytime that we could be dividing by a value that could be zero, we have the same problem in Power BI that we have in Excel. We have basically a division zero or div zero error. In Excel, we would handle that usually with an if statement, checking to see if something's blank or if it's a value that's greater than zero, but we actually have a function in DAX that handles it in a single step. And let me show you then how to create a measure that uses that function, which is called divide. In the sales table, we want a new measure, and that new measure is going to be gross profit percent equals divide. Notice safe divide function with the ability to handle divide by zero case. We're going to divide, and the numerator is in the sales table. But remember that if we start with sales, that's the wrong thing. We have to aggregate it first. So we need the sum in the sales table of gross profit. We then need to sum from the sales table our sales amount. Those are the first two arguments. That gets us our division. And then the third argument that we could have is, what would we like to have happen if this resulted in a division by zero? If we are happy with the result being a blank, then we don't need a third argument. But if we wanted to have something specific, we could have some text that we're returning there. In this particular instance, if there is nothing to divide by, then leaving it blank makes perfect sense. So we're simply going to close this. And then we have one more set of parentheses that we have to close. It says there were too many arguments. I have one too many parentheses, I believe. This is our problem. I didn't terminate that. So divide sum, and it was pointing me to the numerator. Now let's go look at the denominator. That looks good. And let's try this. There we go. Gross profit. Divide the sum of gross profit by the sum of sales amount, and we should be getting a number. Let's go see how this works. I'm going to remove one of our previous visualizations. Create some space. We'll hang on to this in case we want it later. Create a new matrix. And let's drop gross profit percentage in it. That's kind of cool. That's for all sales. So let's take a look now at specific products. And you might think that it's interesting that these are all the same. Well, they're just different colors of the same digital camera. So yes, our gross profit percentage, 0.57. Now remember that if we want this formatted as a percentage, it would be really good if we dropped up here to the model and said this is actually going to be a percent. And we want it to have We've been working with aggregation functions or aggregators. Now we're going to work with an iterator. Let me tell you a little bit about the iteration function. The iteration functions have some of the same names as our aggregation functions, but followed by an X. And here's how they work differently. What an iteration function does is it moves row by row through the table and does a calculation or retrieves some data that we ask about, and then it aggregates it when it's all done. Iteration functions really work in the same way that calculated columns work. So often, the iteration functions and the aggregation functions provide two different ways to achieve the same result. Sometimes we could use sum, or we could use SumX, and it's really a choice which you want to use. But there are times when SumX is exactly what we want. And I'm going to give you an example of that. I'd like to do a calculation on returns so that we can analyze what categories of products and perhaps even what specific products get returned. We'd like to pay some attention to that. I have the ability to calculate my returns for any item because I can multiply return amount times return quantity. What I'd like to do is create a measure that does that using SumX. Right-click in the sales table, new measure, and the measure is going to be named total returns. And total returns is a SumX function. SumX has two required arguments. The first is what table we're looking at, and the table that we want is sales. And the expression is what do we want to be able to evaluate in each row of the table. In this case, I want to multiply return amount times return quantity. And if I use IntelliSense, it will include the table name. And that works. However, in the SumX functions, I don't need the table names. I've already pointed it to a table, and I can simply get rid of sales. Because the X functions, or iteration functions, go row by row through the table. And so in any particular row of the sales table, there's only one value for return amount, only one value for return quantity. Therefore, I'm allowed to simply put these field names, what are called naked fields, or naked references, into this particular expression. So look in the sales table. In each row, multiply the return amount times the return quantity and aggregate that using sum. That's what SumX is telling us. We like this. Now, let's take a look at how this works. I'm going to create a new matrix visualization. I'm going to fire up total returns. And this is the total return. But remember, our goal was to see what product category generated the greatest number of returns. Remember, these are sorted in alphabetical order, but I can quickly sort them and notice that we return a lot of computers and relatively few items in the audio category. Remember also that while we have this particular measure selected, it's a great time to go to the Modeling tab and to change our format so that we have 0 or 2 or however many decimal places you want. And if you want particular currency, you can add that here as well. Finish editing. And return to our measure and to our visualization. SumX is only one of the iteration functions. As with aggregate functions, you'll also find CountX, AverageX, MinX or Minx, Max or really Max, and RankX among the iteration functions. They all work in the same manner. DAX has two types of time and date functions, and we'll look first at the basic functions. If you're used to using date functions and or time functions in Microsoft Excel, these should be familiar to you because most of them are the same. For example, if I have a date and I want to extract the day, month, or year from that date, I simply, for day, for example, would say equal day, open parentheses, stuff in the date as an argument, and close the parentheses. I can retrieve the numerical month and year in the same way. If I have date time information, I can retrieve or parse out the hour, the minute, and the second. I also have access to the weekday and week num functions. Again, the argument that I'm giving them or the expression is a date. And then I have date diff. It's a little bit different in DAX than the standard built-in Excel function because not only can I give it a start date and an end date, but I can indicate whether the information I want back is in days, weeks, months, for example. EO month, end of month, the expression is a start date and whether I'm adding or subtracting months from that, and then return the date of the end of that month. And finally, we have the dynamic functions today and now, equal today, equal now, and these, of course, have no argument. They simply stand on their own. Let's jump back into Power BI Desktop and use one of these. I think we'll use date diff because it's a little bit different here. Here we are in Power BI Desktop. This is the Contoso sales sample. And if you're just joining me for this movie, you'll find this version in the exercise files, and it is numbered 5. This is the promotion table, and the promotion table has what we need to calculate date difference, which is a start date and an end date. In this case, we're going to create a calculated column using the date diff function so that we can see how that works. And we're going to create a calculated column because what we want is for each and every row to know how long a promotion ran. So we have the promotion name, start date, end date. We'll be able to create a nice table with that. We'll begin then by either choosing promotion and clicking the More Commands button, More Actions button, or right-clicking in either event. We're going to choose New Column. Let's name this column Duration. Can always do it later if we wish, renaming, but this is what we'd like. And the function is date diff. Tell me the difference between two different dates. It has 3 mandatory arguments, date 1, date 2, and the interval or unit that we want to use to express the results. So I'm going to start with the start date, which is, if I begin by typing start, promotion start date, comma, end for promotion end date, comma, and then here are my list of intervals. So notice it's date difference, but we can use this to calculate minute difference, hour difference, year difference, and so on. In this case, our choice is day. I'm going to close my parentheses, having now created that new calculated column. And if we want to see that column, we can simply go to our data, and here's the new column, duration, and each of the promotions and how many days that promotion ran. So we've had some real long-running promotions here. No discount runs forever. Every day you can come in and get no discount, but we have some other Now we're going to work a little bit with some of the logical functions. If you're used to working in Excel, you're used to functions like if and, or, and so on. We'll begin by using a logical function find, which allows us to find a substring within another string. And specifically, we're going to use that to find mice in our product list. Rather than creating this as a measure, I'm going to go to the product table and I'm going to create this as a new column. And we're going to call the column mouse and say that mouse is equal to find, and here we have our assistants. The first thing we want to find is text. This is case sensitive. Mouse throughout this table starts with a capital M. So there's mouse within text, and in the product table, we're looking in the product name. The start position is 1. And the report back on this will be similar to the substring function in Excel. So if mouse is the very first word in the name, then it would report back 1. If, on the other hand, the beginning character of the word mouse, M, was in the 6th position in the string, it would report back 6. And if it's not there at all, we'd like it to report back a 0. That's called the not found value. So look in the product name, and if you find the word mouse, then tell us where you found it. Note then that in our very first entry, mouse is in position 24, is where that word starts. And it is a Contoso wireless laser mouse, E50 gray. In fact, if the word mouse appears, then we'll have a number that's greater than 0. And if it does not, find and the logical function if are two functions that I often will use together. I'm looking for something in a product name, a product description, some other text string that's stored in a column, and then based on that, I'd like to do something other than indicate where that string shows up at. So what we're going to do is modify the existing mouse column by wrapping the find statement in an if statement. I'm going to say if. Remember that the result of this find will either be 0 or something greater than 0. So I'm going to say if the result of this is greater than 0, comma, then if it's greater than 0, we know that the string mouse actually appears. And so I'm simply going to put yes. And if it is 0 then, or conceivably smaller, that wouldn't happen in this particular formula, I'm going to say no. So if the result of the find is greater than 0, then yes, it's a mouse. If not, no, it's not a mouse. Press enter and note that our results now have changed so that if the name includes the text string mouse, like these mice here, and at the top, that the mouse column says yes, and if not, it says no. Well, I'm using a Boolean value in this case, yes or no, in the column. We could be using something else instead. I could, instead of saying yes and no, indicate that if it's a mouse, we want the word mouse, and if it's not a mouse, we want nothing. We have a calculated column in our data model that uses find to determine the position of the word mouse within a product name, and then uses if to place the word mouse in our calculated column if there is indeed a mouse in the product name. The problem when you're using find is that find is case sensitive, and there are two different ways you can deal with that. You could either convert, for the purpose of comparison, the string to either upper or lower case, and do the same with the text that's in the product name. That's one option, is a text conversion to upper or lower case for both of the items that we're comparing. The other possibility is if we know something about our product names, and we know that they are usually either lowercase or are proper case, but never uppercase, then we really only have two choices. We could look for capital M mouse and all lowercase mouse. If either of those is found, then it will meet our conditions. And so we're going to add yet another logical function, the function OR, to our calculated column. Before we find, we're going to insert OR and open our parentheses. And then our first logical test is whether we find uppercase mouse in the product name, and if so, if that's greater than 0. So all of this right here is our very first logical expression in the OR statement. I'm going to copy that. Now I'm going to click and notice, in my help, I notice that I'm in logical 2. I'm going to paste this in. And I'm simply going to change one thing about it. I'm going to change the uppercase M to a lowercase m. So I have this long OR statement, and that OR statement actually ends right here at the end of logical 2, and I'm going to close the parentheses on my OR statement. I know that worked because now I'm being kicked back to my if statement. And I need one more thing here. I need to put a comma so it knows that mouse, which comes next, is my result if true. What I've done then is OR to look at this piece of it. Our OR function says either find upper or lowercase mouse. But unlike Excel, where I'm dealing with specific cell addresses and saying, look in this cell address and see if it's this or this. Here in DAX, in Power BI, it's a lot more verbose. I'm not simply saying, look, I'm not simply saying find proper case mouse or lowercase mouse. I have to say, find mouse in the product table, in product name, column, and look starting in the first character of the product name. Calculate is markedly different and more powerful than the functions that we have access to in Excel. With Calculate, there's only a couple of pieces of information that we're providing. First, we're providing something that is either a measure or is a formula that we could save as a measure. And then we provide one or more filters that we'd like to be able to apply during this calculation. In other words, we're overwriting the filters that are already being applied and providing filters of our own. For example, if we were looking at our products table, we could say that we wanted to calculate the number of products, but only where the product manufacturer is Contoso. Number of products is an existing measure that we already created. So it's calculating using all of the products, but we can apply a filter for Contoso only. Or we could provide a filter that says only where the unit cost of the product is greater than $100. Or we could combine both of these filters and run the number of products measure only where the manufacturer is Contoso and the unit cost is more than $100. Let's jump into Power BI. I created a matrix with some information from our product table. Here's our manufacturer and our number of products. And I want to create a new measure using Calculate. So let's right-click, choose New Measure. The name of this measure is going to be over 100, and we'll use Calculate. Calculate, and the expression that we want to use is the number of products, which is a measure that we already created. So calculate the number of products, but we're going to put a filter in place. And the filter that we're going to put in place is that the unit cost in the products table, so product unit cost, is greater than 100. We're applying a filter to the product table so that we can run the number of products and only look at those products greater than 100. Press enter. And now let's add over 100 to our matrix. And you'll notice that A Datum Corporation has 39 products over $100. AdventureWorks 102, Northwind Traders none, and so on. This is how Calculate works. First, an expression, and we've been building all of these measures that are ready to be used as expressions. But any other formula that you enter that could be saved as a measure works here. And then one or more filters that we want to add to filter the calculation that's being done. This seemed relatively easy. What I want to say is that Calculate is one of the more common. There's nothing exactly like switch in Excel. If we wanted to do the same thing we're going to do with switch in Excel, then we would use multiple if statements. We'd nest them together. If we wanted to do this, however, in VBA, we'd use select case. So it's a programming form that we may be used to. Let's add a calculated column to the product table. New column. Our new column name is going to be internal. And internal begins with the switch function. And the switch function starts with focusing Power BI on what field it should find the value from, and then lists what we want to do in response to that value. So what we would like to look at is the brand name column, product brand name. And if product brand name is equal to, in quotes, because these are text values, Contoso, comma, then what we want to do in our calculated column is return internal, comma. That's the first set. So we begin with switch the function name, then look at product brand name. If it's Contoso, listed as internal. And we don't repeat what column we're looking at. We'll never have to say product brand name again because we're simply continuing by saying if it's Fabricam, Fabrikam, in quotes, then Fabricam is internal. If I had other choices I wanted to add, I would simply continue to add them here. At this point, I've listed the two companies I want to know about, and the third possibility is it's not Contoso, it's not Fabricam, and what do I want to do in those instances? If I don't want to do anything, if I simply want to leave the column blank, then I'll end this right here with a closing parenthesis. If, on the other hand, I would like to have external in everything else, then I simply put external in quotes and close my parentheses. Press enter. And our new calculated column lists internal for Fabricam and Contoso and external for everyone else. This is a small example. Power BI includes built-in time intelligence functions. Time intelligence functions are used to be able to manipulate data using time periods to filter results based on a particular time period and to build calculations to compare results from one period to another. For example, 1 quarter to another, 1 year to another. There are some requirements to use the time intelligence functions. First, you have to be using a standard calendar. Many people will say the kind of calendar that hangs on your wall, January through December. And you have to have in your model a calendar table that includes all the dates in the period that you want to analyze. We have a table like that in our data set. Sometimes people will create a table that's just their working days. That's not good enough. You can't skip weekends or holidays in this table. It has to account for every single date. So in a regular year, you'll have 365 rows within that table, in a leap year 366. The only exception in a way is if you start your data set in the middle of a year. If you go into business starting on September 1st, your first year will need only start with September 1st because you won't have data before that time. There are more than 30 time intelligence functions, and they work in groups. The first set actually returns a table full of dates from your calendar or date table. Dates year to date, for example, will return a table with all the dates to the current date for that year. There are two similar functions, quarter to date, dates QTD for quarter to date, and dates MTD or month to date. Next, we have next year or next quarter, month, or day, which returns a table of all of the dates in that time period. Previous year or quarter or month or day is similar. It returns, again, a table with all of the dates in the previous year, the previous quarter, and so on. Same period last year takes the current period, whatever it is. If your context is this month, it will go find those same dates back a year. So same period last year returns a table of dates backed up a year from your current context. The next set of functions return specific dates. What is the date for the start of the year? There's also start of month and start of quarter. Similarly, end of year, end of month, end of quarter dates. Opening balance, which can be for year, month, or quarter, finds the first date of that period. So opening balance year is used to find the opening balance on the first date of the year. Closing balance is the same. Total year to date and its companion functions, total quarter to date and month to date, are used to evaluate We're going to use the calculate function with dates year to date to be able to create a new measure that is sales year to date. We'll put this in the sales table and choose new measure. And we'll call this measure sales YTD. And this is equal to, and let's call the calculate function first. And we're going to sum sales amount, which is found in the sales table. Now, we've actually built a measure like this previously. So far, so good. But now what we want to do is use the time intelligent function dates year to date to go grab a table of the dates in the year. So here's dates year to date, and we need to give it a date key to look at. That's right here, calendar date key. We can just close this off and press enter. Now it tells me I have too many arguments for the sum function, and that's because right back in here I needed another parentheses. And that makes the one at the end extra. It's got a little red underline and it helps me out here. That should be correct. And it is. That's great. So now we have this amount in sales year to date. I'm going to throw in a brand new page here and drag sales year to date, and we get nothing. And the reason is our data in the sample ran out long before the current year. So what I want to do is change the context, and I'm going to do that by placing a filter on the visual. I could also place the filter on the entire page, and that would be fine. And if I were to do that, I can drag year down here to filter this page, and it says year is all. I'm going to choose basic filtering and choose a specific year like 2011, which is in our data range. And here we go. This is the sales year to date in 2011, which in 2011 equates to all sales. But if we were to choose our current year, or we had a current data set, then this bar would increase presumably every day as we made more sales. If you'd like to see how it looks for a different year, this is a little over 3 billion. Let's take a look instead at 2013, when our sales were lower. So this measure is working properly. And it lets me see the sales year to date for the filtered context, which is if the year is 2011, what are our year to date sales? When you understand how to use dates YTD, that opens the door to a whole range of functions. Dates QTD, dates MTD for quarter to date and month to date, the next year, quarter, month, and day functions, previous year, and same period last year. All of them return a table of dates that you can use as a filter, really, just as dates YTD functions. We have a measure that allows us to track sales year to date that we created using the dates year to date time intelligent function. Let's do a little bit more with this, though, because this visualization doesn't give us very much. So let's begin by putting some months in here. And I'm going to go to the calendar. And if I use month name, I'll get months, but they'll be in alphabetical order. What I want to use is the actual month that's part of the date key right here. And that will give us the months, but it will give them to us in chronological order. And I'm going to switch my type to a matrix, give it a little more room, and format this so that my values are a little larger and we can actually see them. Spin that up. That works. And of course, we can also change our heading sizes and our label sizes so they're also visible. So here come January, February, March, April, May. And remember that our context, because we have the page filtered, is that the year is 2011. So this is really cumulative sales. Each of these periods, it is showing me the sales for the year to date, which is exactly what we created when we built our new measure down here in the sales table. What I'd like to do, though, is also show the monthly sales, and that is the sales amount column that is already summarized. So I'll drop it in there. And typically, we would have these two columns in reverse order. So Year-over-year sales are used frequently to view the performance of an organization. This is how we did this year. How did we do the year before? So let's see how we use same period last year to be able to create a new measure that will give us that information, which we can then add to our matrix. We already have a measure for total sales, so that's easy for us to use, and in fact, we're using it here. I'm going to remove sales year to date so that all we have are our monthly sales, and in this case, the year is 2011. I'm going to actually change this to 2012 because we didn't start business until 2011, so we don't have any 2010 sales. If we looked at our previous year's sales, it would be a big flat nothing. And let's begin by creating then a new measure. And the new measure that we want to create is our total sales last year, LY. And that is equal to, and we're going to use our general calculate here, this very, very powerful function that we learned earlier. And we're going to base this on the total sales measure we already have. So you begin typing, and measures, of course, show up here as measures. So this is total sales. Calculate total sales, but what we want to do with total sales is now throw this same period last year function in to return a set of dates that match up to these dates, but in the prior year. There's one more argument that is needed here, and only one argument, and that argument is our date column, which in our case is called date key. And we'll just close this. And we've now created total sales for last year. I'm going to check this to add it. And here are my sales for this year and my total sales for the prior year. If I wanted to filter this, for example, by quarter or by month, I could do so. And I would only receive results from the same quarter or same month in the prior year. This is sweet, and from here I might choose to create some additional measures that would, for example, You've come to the end of this course, but this is not the end of what you can learn about Microsoft Power BI and DAX. First, before recommendations, don't forget that your best next step is to post your certificate of completion for this course to your profile on LinkedIn. There's a button that will allow you to do that. Then some recommended next courses. If you're interested in Power BI in general, not just data modeling, I recommend Power BI Essential Training. If you're looking for more adventures in Power BI, Helen Wall's Advanced Microsoft Power BI course, and in the marketing segment, Chris Dalavia's Power BI for Marketers courses are all available in the LinkedIn Learning Training Library. It's been a privilege to create this course for you. You can find me on LinkedIn and occasionally on Twitter. Until our next time together, be well in the world.